All right. Okay. Hello. Good day, everyone. So we are from the language team, and I'm Celine from Unimas. And okay, first I will introduce our team. So I'm Celine from Unimas, and I have a background of software engineering, and another Celine from VU Amsterdam, and she has a background of artificial intelligence. And we also work with Vlad, who is currently working on this topic, and he has a background in artificial intelligence. So he will help us present the topic more clearly after this. So he'll continue.
Oh, if you listen to my presentation at the beginning of the month, I'm working on a project to create a language recognition software for that don't have them, languages that are obscure, that are used in areas with not a lot of coverage or interest for large data companies. And that goal, I decided to collect words from people and use them to train a machine learning model to um, to understand words automatically without the need of human intervention. So we identified two stakeholders. The first stakeholder is us, the developer, and the other stakeholder are people who live in rural areas of different countries who might not have a very high literacy level and for whom um, communicating through words, through spoken word, is much more convenient and much more effective. And we started by collecting audio data, and actually at the beginning course we invited all of you to record these recordings, and thank you very much, because we collected close to 100 samples from you, and we use those samples to make our model. Um, we spent a lot of time pre-processing our data because, as it turns out, there are many obstacles to adapting the sound files to the model. But to give you a short understanding of how we do this, is we files which are stored in a small format that can be easily saved from any internet connection, and we converted them to WAV files, which are basically raw files with no compression, and they fed this into our model, and we tried many different options and parameters and number of samples to see if our accuracy can improve, and then we updated new data we created ourselves. So we, instead of using directly the audio data, we converted audio data, as seen in the slide here, in the pre-process the data step. We converted all the audio data into MEL spectrograms, which are representations of the frequency of the sound in image format, and in a level that is easy understandable for humans. The distance between frequencies is similar to how humans hear sound. So that's called a MEL scale. So that's why they're called MEL spectrograms. And we trained this model, and we found more data on the web that we could augment to our data, and we also added noise, and we changed the pitch, and we altered our audio to adapt it to more data for our model. And we tried with different quantities of data, and in the end we noticed that, of course, the more data we have, the more we wanted to see that even with just 200 samples, audio samples, we were able to get an accuracy of 82 to 84%. And now I will give the floor to demo an animation that we've made, which is something that it's an example of how farmers could possibly use such a system to get information about farming. Go ahead, Sunil.
Okay. I will share the video.
Oh, you need the video? Oh, 1 second.
Yeah.
Maybe it's easier if I share it.
Yeah.
Sorry about that.
Can you share?
Let's see. Let's see. Oh, 1 second. Here it is. So, move this out of the way. Here you.
Okay. So basically, this is how we can apply the language model. For example, to a web application. Like we made a sample of a farming help system. So at the main page, like instead of typing or instead of typing and other or clicking buttons, we can just apply the language model, and people can speak directly to the system. Like that you can say. So it works like, so it will catch what you say, for example, yes, and then we'll continue. Yep. So the main thing here is basically how we can apply the language model to an application. So this is one of the examples. Okay, I think that
Yes.
can continue.
Yes, so this way you can choose type of information with simple yes or no. And as Anna already knows, this is a preliminary system because later on we can add more words that help make it even easier. Because of course with yes and no it can take longer. But this is a good sample of how well this can work and how much easier it makes it. And keep in mind that this will not be online, of course. It would be through a phone, so through a phone call. And they will be asked these questions and they can say yes or no, and then they will get information. So it will not be in text. This is just for the demo to show an example of how it might work. Okay, I'll continue. So yes, we call it the farming help system, our demo. And here I will tell you about the process we went through. So in the first week, we spent a lot of time gathering data, and we sent it to many of our friends and groups and people on this course, and we collected as much data as we could. We chose the English language because it was more convenient in the short span of the course to collect enough data. I think if we would have chosen a more obscure language, it would have maybe not given us enough data to make a demo of it. We went and processed the data, and this took quite some time because apparently there are many differences between browsers and how they record the audio, and all the audio needs to be put together. And I will look more into about this in the problem section. We then tried a few models, and we found one that worked quite well for our data. And we tried, as I said, with augmented data, with additional data from the web. And we also did the web application to connect it to this model. So basically what happens now is we save the model, and the application can simply send the sound of a voice of someone to the model, which will be on a server, and the server will reply with probability of what the word was. So if yes has a probability of 98%, it will give the probability for yes, and then the probability for no will be 2%. That's how it works. Those we encountered involved audio encoding issues. So basically, everyone uses a different browser.
Can you wrap up in 1 minute? Is it possible?
Okay. Yes. So everyone uses a different browser, and different browsers silently use different formats. We had processing issues because many of the files needed to be processed manually. So we split the files between us and we manually processed. And we had difficulties adapting the sound to the models we use. So as you can see, when we added 2,000 samples of yeses and nos, we got an accuracy of word recognition of 97%. And of course, the lower we went, the lower the files, and we already had 90% accuracy. So for just these two words, it's not necessary to have a lot of files. Yes, let's see, 1 minute, right? And a conclusion in future work. So we want to make language models for other languages, as I said in the beginning. We want to improve the web application so that it's fully functional and can be used directly. We want to solve all these encoding compatibility issues so there's no issue in between the model and the application. We want to try different parameters and different models because the more words we add, the accuracy would be more difficult with low amounts of data. And that's it. If we have any questions, go ahead.
Thank you. Thank you, Vlad. Thank you, Celine. And also thank you, Celine, who could not be here. Nice project, nice work, very interesting research. So I open the floor for questions. Are there any questions?
I would like to ask question. Anna?
Yes, please.
Okay. Yeah. Okay. Is it can be applied to any language?
Yes, it can be applied to any language. And what we can say is that it will depend a lot on the language, the accuracy, but it's very likely that if the difference between yes and no in a specific language is large enough for the human ear, then the accuracy will be high also for the model.
Yeah, because I'm quite interested in this project because Sarawak itself has I think many language of that kind that is very little resource that we can find for that language. Even sometimes the native speaker also didn't have that vocab, especially the newer generation for their own language.
Yeah, exactly. It's perfect for exactly those situations, and this is exactly the target we have. Of course, for English, we already recognize yes and no in many with many different models and created by Facebook or Google. But it was just for an example. But it's intended for exactly languages that don't have this kind of support.
Okay. Thank you. Great work, Vlad and the groups.
Thank you very much.
Yeah, so with that, the question from Prof. Kartina, Vlad and Celine, it's very important that you package your project such that it can be reused also after you finished your project, because it's very interesting for further research and for to use it for different languages. I hope that you can do that because that's very interesting. And for Vlad, it's part of your master project. So it's challenging. So are there any questions more? And I don't see them. And I think we are running a bit out of time. So it's very good that we can proceed. So I give an applause to this group also. Very nice, group number 5, very good work.